Okay guys, I was looking at this and drawing two bell-shaped curve to calculate the equilibrium as far as the SMV is concerned. Uh, Really the hard time for us is to raise it between uh, this this point, because this is where the peak jump happened. This is the steepest part. So the steepest part in your life, and this equation, the steepest part would be from here till the point like here. Everything is like quarter of line, and, and the steep curve is like something unbelievable. The degree that happens change from these coordinates from 30 to like when the x-axis become 30 to 35 units. The slope of the curve is like tremendous. If you see the slope of this curve, it slows down. The highest rate of change happens at when x-axis. If I draw a tangent here, that tangent would show me that this is the fastest rate of change. Now, this happens so fast that it's very hard to understand uh, how quickly the scenario changed. Likewise, this goes slowly here. The fastest change of curve in this case happens somewhere, because here it's slowing down. So the fastest rate of change is like here. When it's going down, the curve goes down steeply. Because the rate of change here is slow, it increases, it becomes the fastest here, and then it slows. So the convexity of the curve changes at this point, and this is again change point. Because at this point, the slopes are inverting, and the convexity is changing. Uh, at this point, uh, the uh, the green curve we don't understand, and we are taken aback by this abrupt change. And at this time, the change is going down, so they should know. And also because once the remainder, once the tens decimal place is changing, it's like a big change. So now uh, after this, it's like if you draw a straight line to find out the equilibrium points here, it becomes very hard. So if you are here, you can probably head somewhere here. So this is your only range that becomes. I mean, you cannot really think from here to make a big jump here. That's like kind of impossible, and that should never be done. Uh, Once you hit this point where the rate of change changes and there is an inverse, and the convexity of the curve changes, then it's very hard to bring that back. The best time is still this point, so I'm going to mark that for you, the peak. So this is the peak. Oh, try that again. So this is the peak, and at this peak, the best equilibrium point become this peak. So this is the matching point when the coordinate system says these numbers. All right, now if my current equation is this, and to find out an equilibrium case, it would be something like this. So it's still like close or matching if these happen. So you have to draw a straight line, go to this point, map that point here, and bring it down. If you are in this part, then it goes down. So when you go up, this curve goes down. So each incremental on this till you reach the asymptote, you have, 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 you have to realize that you have to map it on the back. So when I find a position here, I'm completely disillusioned that it's like game over on this point, because when you map it on the left, like I was mapping this on the left, it's like there is no point. The mapping point becomes on the left, which makes no sense. So it's it's kind of over after the inflection point when the curvature changes. So and and at this point, the, the second degree, the rate of change becomes 0, and the other thing changes. So this is like the third differential that you have to find out to make sure that that curve happens, and you have to map this whenever you're looking at something. Now, at this point is like a lot of things that are like, yeah, something insane. So it's a completely bad wall on this part of the graph.